So for Brinell hardness testing, to arrive at BHN or Brinell hardness number, the specimen is used as aluminium, and you can see the specimen and the uh, all the details are being printed on the side, which you are able to see it. Okay, and this is steel ball indenter. This is what we will use to make an indent. Okay, steel ball. I hope. Yes. And this is 10x magnifier, which will be used to see the small d. What is that small d? It's a diameter of indent which has happened on the specimen. You can see that there are some experiment which has been already performed on this specimen, and that's why you can see this indents on the specimen already. Okay, so what we'll do is we'll try to find out the plane surface and then apply the force. So the force which will be applied in Brinell's will be as you can see, we will make us, what we'll do is we'll try to set up. So here is what is done is load setting is performed, and you can see that for this side the Brinell setting, load settings will be done. From this side the Vickers load setting will be done. Okay, so for Brinell's we will have a load setting of 62.5 kg. Okay.
Hi, this is our hardness testing machine. Here we have a Vickers loading arrangement, and here Brinell loading arrangement is there. So this is our indenter. For Brinell we have to use the ball indenter. This ball is there, no steel ball. The die of the ball is 2.5 mm. Here, come here. Here we have to place the indenter. Like this, we have to place the indenter. Right here. Then this is the magnifier. This is the magnifier to measure the dia of the indentation. Here, just push this, and here we have to fix the indenter.
So this arrangement is done in order to, using this you will apply and load. Okay, the moment load is applied and it is released, automatically the setting will may ensure that you actually can see using this magnifier how much indentation has happened. Okay, yes.
Then place the specimen here. Here we have some dimensions. Measurement is there. There's 62.5 is there. No, that means we have to select the load here. For Brinell test, we have to select the 62.5 kg load here.
Okay.
Then place the specimen here. Switch on the light. By rotating this screw, zoom the specimen. You have to see here. See. The surface is clear visually now. Here that impression is there, old impression is there. Just move this and select a fresh area. Here no impression is there. Leave. Then select the load here. the load 62.5 kg is selected. Then here we have a green button to apply the load. Just press this one. When we are pressing this, the hand lever is going to slightly slowly raising this for a 10 seconds. After 10 seconds, we have to gently release this angle to release the load. Just by pressing this. See here, that impression is coming.
I'll just
Then
how will
just slightly moving this, make it center.
how so what you are seeing here is how to measure the indent happened on the specimen. So when we are saying the measurement of small d in case of Brinell hardness number, how to go about it? So actually what we are doing is we are using 3 scales to arrive at the value of small d, or you can say the diameter of indentation. So the first is microscopic scale. So here, from here you can see, using macroscopic scale you will arrive at the value, since it has a least count of 0.1 mm, so you will get the first digit after the decimal in terms of mm from the microscopic scale. Then there comes a vernier scale. In using vernier scale you'll arrive at the since it has a least count of 0.01 mm, you can easily know up to 2 decimal places the correct value. Then you will use micrometer scale, that is the third scale, to arrive at the digit after the third digit after the decimal points. So using all these 3 scales you can accurately measure the length of that indent up to 3 decimal places. So like if the indent has happened up to, let's say, 1.243 mm, so that's what 0.2 you will get it from microscopic scale, 4 you will get it from vernier scale, and this 3 you will get it from the micrometer scale. Okay, similar setup is there for Vickers. Okay, similar setup.
For fine adjustment, just use this micrometer. The any line should be coincide to this side. Here one line is there, no? It should be coincide to the corner of the impression, like this, rotating. Now this line is coincide, no? From this line, we have to measure this line. How many number is inside the impression, how many line is there, we have to count down. That is the microscopic scale.
So how much is
That
that?
means here the first one is 0, 1, 2, 3, 4. You have to measure this line. That means 1, 2, 3, 4, 5, 6, 7, 8. Inside impression we have 8 lines. That means microscopic scale is 8 into multiplied by the least count is 0.1. Next we have to see vernier scale. Here vernier mentioned 0 is there, no? Here we have to see 0. From here middle line is there, dark line is there, no? From the dark line, vernier scale 0, where we have to coincide, that we have to see. Here 6th line is coincide.
Okay.
6th line is coincide here.
Yes.
Then the second scale is vernier scale value is 6 multiplied by the least count is 0.01. Next the third scale is micrometer scale. Here you have to see, here 4.5 is there. So that this line is crossed to the 4.5. That means you have to take it as 4.5. The third scale is 4.5. Multiply by the least count is 0.001.
0.001.
So now the measurement of the Brinell test is over.
Over. So you will add all these things to arrive at the final value of
final
diameter
impression.
of impression. So like this you will be doing for 3 times, so that at least you will be getting a 3 readings, and that way you will get an average diameter of indentation, and then you can arrive at the value of BHN. Okay. So students, now think, you are given that at microscopic level the value was 8 multiplied by 0.1 mm, so you will get 0.8. Then in vernier scale it was 6, so if you multiply 6 division by least count, that is 0.01 mm, you will get 0.06 mm, and in micrometer you got the reading as 4.5. So 4.5 multiplied by 0.001 mm, that is, it will give us 0.0045 mm. If we add all these things, we'll get the final value of diameter, that is 0.8645 mm. So that is one reading or one reading of indentation diameter which you have got. Okay, likewise if you do for 2 more times, you will get 3 values, then you can average it out and then use that value to calculate the Brinell's hardness number. So for Vickers hardness number, we have these setups where all 3 specimens are mild steel, but the specimens are used for different load settings. So this specimen of mild steel is generally used for 30 kg load setting. This specimen for mild steel is being used for 10 kg load setting, and this specimen for the mild steel is used for 5 kg loads 5 kg load settings. Now if we are using this specimen where the load setting will be 30 kg, we can actually use 10x magnifier, which was being used in Brinell's hardness number. But if you are going for 10 kg or 5 kg load setting and specimen corresponding to it, we will be using 20x magnifier lens. Okay, and in this case the indenter will be as you know, the material which will be much harder than mild steel, and here in this case we are using diamond. So you can see this, I hope you just a minute. So you might be able to see the face cut and the face angle the angle between 2 faces in this case is 136 degree. Okay, so this is the diamond tip, okay, which will be used to indent the specimen. Okay, so now what we'll do is we'll set up this thing which you can see.
So same as Brinell, place the indenter here.
So indenter has been placed.
On the magnifier I have to place here.
Now magnifier is getting placed or getting set up with the instrument.
Now we are selecting 10 kg specimens. That
So-
means it will carry up to 10 kg load.
So we are using a specimen which will undergo 10 kg of load.
Here written here HV.
Just a minute.
HV means Vickers hardness.
uh,
Here 10 is there, no?
10 written.
Okay,
Yes.
then place here. We switch on the light. Zoom the specimen. We have to see here. See, the surface structure is clearly visible now. Their old impression is also there.
So with this what you will be able to see is whether you are seeing the plane surface or
Surface.
the surface. It should be very plain. So if it is having irregular shape or it is already indented, then what it will do is it will disperse the light very much. So if it is very plain surface, what you will able to see is very sharp reflection and not the dispersed reflection. Okay, so I think in the video you are maybe seeing this dispersed, but through eyes if you see, you will see the sharp reflection from that surface.
Yes.
So
Then you have to select the load of 10 kg here.
so
Just pushing this.
So 10 kg load has been selected at Vickers scale. Then
Press this green button. The load is applied. Within a 10 seconds, the load application is done. After 10 seconds, just release this handle gently. When we are releasing, the indenter will come back.
so indenter will come back and the magnifier
going to
lens
center
will be
that.
in that position where the indent has happened. So again what you will do is you will try to see.
See that impression is well scanned.
Now you will able to see the impression. Can you?
Square base impression
You and it has been easily been shown here in this Vickers, the square base intention. Now the setting has to be done.
Now just release this by losing this. Just rotate like this. We have to measure the diagonal distance here. We can't have to measure the diameter, no?
Exactly. So in Vickers case, we are actually trying to measure
Just losing this,
the
rotate,
diagonal of the square.
360 degree.
Yes.
Then set like this. Right here. For fine adjustment, just screw it through micrometer. This line should be coincide to the corner. Now the line is coincide now. From this line, we have to measure the how many number of lines is there in that impressions.
So what is being done is, if you see, the setting is performed in such a way that this one corner of the square, the line which is just coinciding with that corner, now will try to read how many lines it takes. So the reading is,
when we are measuring, here one line is there now. This is for vernier scale. Here 0 is mentioned here.
right.
We have to neglect that line.
Okay.
Need not to write that one. So this is a 0 line.
0 line. 1, 2.
This darker line is there, no? 2.
Yes.
We have to neglect this. I said no. We have to neglect this.
Right.
Here inside the impression we have 2 lines.
2 lines.
So the microscopic, that means the scale 1 reading is 2 multiplied by the least count is 0.1.
0.1. Yes.
The next is vernier scale. That means second scale. We have to, where the 0 line is there, no? Where the 0 line is coincide, we have to see here. Here also fifth reading.
So we'll just
The line in the vernier scale 0 in between 5th and the 6th line. That means you have to consider as a 5th line.
So
The second scale is 5. Multiplied by the least count is 0.01. Then next, third scale. You have to note on this one. This is a micrometer. Here 0.5. That line is just crossed 0.5. That scale is 0.5 and multiplied by the least count is 0.001. So summation of these three, you will get the one side diagonal length.
yes. So
Then we have to measure the another diagonal length.
right.
Just lose this and rotate and set into another diagonal length. Just tight here. And do fine adjustment. Now we have to note on the number of line inside that means in between the impressions. Here also same, two lines is inside the impressions for scale.
Right. So you can see there are two lines here. This line which you are able to see here, it is a vernier scale line which you have to neglect. So this one line which is just touching the corner of the square, then that one, from that then you count 1 and 2. So there are two lines.
Okay, then we have to note down the second scale, that means vernier scale, where 0 line is coincide. That is here 6th line is coincide.
So we have to zoom in and just see which line of vernier scale is coinciding. So just a minute, I'll try to focus. So you can see that you have to find out which line will coincide with the vernier scale, and here it's 6th reading will coincide with this bigger line. So the vernier scale is this small lines, and the coincide of which line of vernier scale coincide with this 0 reading, that we have to check. So this is the sixth line vernier scale division which is coinciding
The second
with 0.
scale is 6. Then third scale of micrometer scale is here 5th line is
So,
coincide. Here on mark
the
is
third
there, no?
scale
For that,
micrometer, yes,
5
there
is
exactly 5
5.
is coinciding with this. So we got our third reading as well. So first is microscopic reading, that is we had 2, so 2 into 0.1. Then we had vernier scale reading, that is 6 division multiplied by least count, that is 0.01 mm. And third is micrometer scale reading, and there we fifth division coincided. So 5 into 0.001 mm. So if you sum all these things, you will get the second diagonal of the square. So first diagonal and second diagonal is known. You take an average out of it and use that value to calculate.
And then here we have to apply the divide by 2 because we are using 20x now. That means what we will give the impression, it will show in twice times.
Right.
That means after that summation of these three values, you have to divide it by 2. That means d1 by 2 and d2 by 2.
Why?
You get the exact value of the impressions.
Right. Why we are doing divide by 2 is because we have used a lens which was 20 times.
2 times.
2 times. So 2 times of what earlier the lens which was used. So here it will show, just a minute. So
20x magnifier.
Okay. So this you'll divide by 2.
If you are using 20x magnifier, you have to divide by 2 because it shows twice of the 10x now. That means you have to apply that divide by 2.
Okay. Thank you.